Welcome to Real Learning Center. We have been discussing various topics under numbers, and today is our final topic, that is prime factorization. So, as a subtopics, we will first discuss about what do you mean by prime factors and what is meant by prime factorization, and then what are some interesting facts about the same. And then we will see how exactly to find prime factors of a given number, and later we will see what are some of the interesting uses of prime factorization. Let's start. Now, what is prime factorization? Till now we saw, in our third session we saw what is meant by factors, and in our fourth session we saw what are prime numbers. So let us combine both to understand prime factors. Okay, prime factors. So let us take example of number 6. If you factorize number 6, we get, different factors are there, 1, 2, 3 and 6. It's not equal to factors of number 6. So among them, we have got total 4 factors. In that number 1 is neither prime nor composite, and number 6 is a composite number because it has factors other than itself and 1, so it's a composite number. So the prime factors of number 6, prime factors 2 and 3, because 2 and 3 both are prime numbers and they also are the factors of number 6. Hence, prime factors of number 6. Two and 3. And in the example what I have given there, we have taken number 21 and we have factorized it into 2 prime factors, 3 into 7. Both 3 and 7 are prime numbers and they are also factors of 21. So 3 and 7, they are the prime factors of number 21. Having understood what are prime factors, now let us see what is meant by prime factorization. Yeah, you can see here the definition of prime factorization. Now, what is prime factorization? And the prime factorization is possible for every positive integer. So what does it say? For any given positive integer, so in our example, say it is 21, okay, prime factorization is a list of integers which are the prime factors of this number. For example, prime factors of number 21 are 3 and 7. 1 is not a prime number and 21 itself is another factor of 21, but it is composite number. So the prime factors of number 21 are 3 and 7. So prime factorization of 21 is 3 into 7. This is the prime factorization of number 21. And we have used the substatement of together with their powers. So let us take another example for that. We take 4. So what are the prime factors of 4? 2 into 2. There is only one prime factor, that is 2. So now 2 into 2 we represent as 2 square. So this is the power we are using. 2 square we write like this. So this is the power which the prime factor is raised to get the original number 4. So it's a combination of prime factors together with their powers. 4 is equal to 2 square. Now let us take another example of 8. How do you factorize 8? We know 8 is nothing but 2 into 4, and again 4 is a composite number, so we have to further break it down. When you further break it down, you get 2 into 2 into 2 the same as 2 cube. So hence we can say that the prime factorization of 8 is 2 cube. Okay. Yeah. So to shorten the representation, instead of writing 8 as 2 into 2 into 2, I use powers. Another word for powers is multiplicity. Means how many times you multiply 2 to get 8. Here it is 3 times. Okay. So this is called as power or multiplicity. Now we take a bigger number as example. So here the number is given 360. Now how is 360 split? It is initially split as 2 into 2 into 2, 2 cube, into 3 into 3 into 5. So now raising them to powers, I mean there are 3 2's, there are 2 3's, it becomes 2 cube into 3 square into 5. So 360 written as, just a minute, it is not clean here, yeah, 360 written as 2 cube into 3 square into 5 is the prime factorization of number 360. Having understood what is prime factorization, now let us go to the next step. How do we find prime factorization of any given number? Oh, before that, before we go to how to find it, let us see a couple of interesting facts about prime factorization. Interesting facts. So this task of finding prime factors, we took a small example of say 360. But suppose the number is quite big, say it has 5 digits, then the task of finding prime factors becomes a bit more difficult. Now increase it to 6 digits, 7 digits, task becomes more and more complicated. We saw the number 21. The speciality of number 21, you can see here, is there are only 2 factors and both the factors are prime numbers. So whenever we have such numbers where both the numbers are, I mean there are 1 or 2 numbers, they are prime numbers and they are raised to power 1, means they are only once present, then to find these factors becomes a bit difficult. See, for 360 we know it is divisible by 2, we can start by 2, okay, but if there is a bigger number which is not divisible by 2 or 3 or 4, then the task becomes more and more complicated. So as a result, to find the factors, the prime factors of given number becomes difficult. Say it has 6 digits, 7 digits. So the largest known number which has been factored is known as RSA 768, which has 232 decimal digits. And incidentally, it is the product of 2 large primes. Another very interesting fact, we can construct a problem to determine the prime factors of some number, say it can have some 1000 digits or more than that, whatever. So now the task is to find prime factors of that 1000 digit number, and this task is so complicated that current day big computers, supercomputers with existing techniques or algorithms to find prime factors will take longer than the age of our universe, that is about 13.7 billion years. More than 13.7 billion years it takes, I mean, to find the prime factors of such large numbers. So in this way, this concept of prime factorization is greatly used in encrypting or cryptography, what we have discussed in our previous session. So to factorize a given very large number into its two larger primes is, very complex task. Hence the field of cryptography and information security. Now let's see how exactly to find prime factors. Yeah, in our previous class we just touched upon this concept of fundamental theorem of arithmetic, which was given by Euclid. Now we will use this concept of fundamental theorem of arithmetic. What does this theorem say? This fundamental theorem of arithmetic says every given number, take any number which is greater than 1, then either that number is prime, either it's a prime number, or we can represent that number, say for example the number n, we can represent them either it is prime, or we can represent that number as product of prime numbers. So this is the fundamental theorem of arithmetic, the basic concept in the field of arithmetic, and this has been widely used nowadays. And another very important fact is that you take a number, positive number, and then you find its prime factorization. Okay, what is prime factorization we have seen in our previous slide. And once you find the prime factorization, we can be rest assured that it is unique. Means for every given number, say for example 8, say I start finding prime factors, and I saw that it is 2 into 4, but 4 is further split as 2 into 2 into 2, now it is 2 cube. So 8 represented as 2 cube is unique. There is no other number which is 2 cube, right? So we cannot represent 8 in any other way. Unique way is 2 cube, using only prime factors. Okay, if you don't use prime factors, you can write it as 2 into 4, but using only prime factors, the only way to represent 8 is 2 cube, and 2 cube only refers to 8 and no other number. So hence prime factorization of every integer is unique. So this is very important concept. That is one of the main reasons why we don't consider 1 as a prime number, because if you consider 1 as a prime number, then 8 is equal to 2 cube can also be written as 8 is equal to, 2 cube is 2 cube into 1 we can write. Then both are not unique. Hence, to remove that confusion, 1 is not a prime number. Hence, when you factorize a given number into its prime factors, there is only one way to do it. So how to do it? How to do a prime factorization? Let us take some examples to understand how to do it. So simple examples I have already taken. I will take a bit bigger number, say 36. Now how do you find prime factors? Now what is the first known prime number for all of us? 2. So start dividing by 2. We do sequential division starting from 2. Now 2 18s are 36. You know that. So now this is one of the prime factors. And is 18 a prime factor? No, it's a composite number because we can divide it by 2. So continue the process. Again divide by 2, you get 9. Okay. Now this is the second prime factor. And what about this? Is this a prime number? No. It's a composite number. It can be divided by not 2 but next prime number, that is 3. 3 3s are 3. And now what is this 3? This is a prime number. So stop the process. So we have got all the prime factors of number 36. So we can write number 36 as 2 into 18. 18 is further factorized as 2 into 9, and 9 is further factorized as 3 into 3. So in our shortened form, it is 2 square into 3 square. So this is the unique prime factorization of number 36. Let us take another example, say 64. Okay, start doing division. It goes by 2, yeah. 2 3s are 2 2s are 32. Now 32, is it a prime number? No. Continue. 2 16s are. Again 16 is not a prime number, so continue. 2 8s are. Continue, because 8 is not a prime number. 2 4s are, and finally 2 2s are. Yeah. So now I have got all the prime factors of number 64. So I write 64 as 2 into 2 into 2 into 2 into 2 into 2. It's nothing but 2 1 2 3 4 5 6 times. 2 raised to power 6. So in this way, we can find prime factors of any given number. Now for smaller numbers, this is quite easy task. Now suppose I asked you to find prime factors of a bit bigger number, say for example 360. We can follow the same procedure always. You can start dividing it by 2, and then you get it as 180, and then again continue, get it as 90, again continue. Now it doesn't go by 2, so start by 3. Now 3 5s are. So we got about 1 2 3 4 5 6 factors. We have seen it before. Now for such numbers where you can actually guess some of the factors, for example 360 can be written as 36 into 10. Now we can further easily subdivide, because we know the factors of 36, that is 6 into 6. Okay, or you can take any number, because it is unique always. I can write as the 6 into 6 into 10, or suppose I write it as okay, I'll do it later. First I'll complete this, and then 2 into 3 into 2 into 3. 6 is written as 2 into 3. This 6 is written as 2 into 3. Now 10 is written as 2 into 5. Now grouping all 2's together, we get as 2 into 2 into 2, and next prime number is 3, 3 into 3, and next finally 1. So we get the same number, 2 into 2 into 2, 3 into 3 into 5. We get the same thing. Now to show it's unique, now I start doing it like this. For example, 360 is equal to, I'll do 36 into 10, but now instead of 6 into 6, I'll do it as 12 into 3 into 10, because I know 12 3s are 36. Now what happens next? Now 12, we know it is 4 into 3, 4 into 3 into 3 into 10. Further splitting it, we get 2 into 2 into 3 into 3 into, again 10 is 2 into 5, which is same as this number. Of course, this 1 2 we can write it here, so both are same. So we always get unique prime factorization, no matter how it is split in between. In the end, we always get the same prime factorization. There are many uses. To start with, highest common factor for any given pair of numbers or more than 2. To start with, we take 2 numbers. Say for example, we have got 16 and 24. Now I have to find common factors. Not just that, I have to find the highest common factor. So now, what are the factors of 16? 1, 2, 3 is not there, 4, 5 is not there, 6 is not there, 7 is not there, 8, then 16. What are the factors? of 24. 1 is there, 2, 3 is there, 4, 5 is not there, 6 is there, 7 is not there, 8 is there, 9 is not there, 10 is not there, 12, and final 24. Now we have got the factors of 16 and 24. Now there are common factors, we have seen in our previous class. Common factor is 1 and 1 and 1, 2 and 2, 4 and 4, and 8 and 8. Among all these common factors, which is the highest common factor? That is 8. This qualifies as highest common factor of numbers 16 and 24. Many a times when I use the word highest, people get confused. Oh, is it bigger than the given numbers? No, because we always know that the factor of a given number can be at the maximum the given number. I mean the factors of 16, maximum possible value is 16, not beyond that. So the factors of 24, maximum possible is 24, not beyond that. So the highest common factor of a given number is always less than or equal to smaller of the given two numbers. So given two numbers are 16 and 24, smaller of them is 16. So the highest common factor is 8, which is smaller than 16. The highest common factor is always lesser than the least of the given numbers. So how to find highest common factor? So what do? I start doing prime factorization of number 16. Now I do prime factorization. 2 8s are 16, 2 4s are 8, 2 2s are. So 1 2 3 4, 2 raised to power 4, 16 is equal to 2 raised to power 4. Estimate. And now I start doing prime factorization of 24. Again 2, 12, 2 6s, 2 3s. So 24 is equal to 2 cube into 3. Okay. So we have got the prime factors of 16 and 24. Now after finding the prime factorization of the given two numbers, how to find the HCF? It's quite easy. Take each prime factor. Now we have got prime factor 2. Now in the case of 16, 2 is raised to power 4. In the case of 24, 2 is raised to power 3. Take the minimum, because it should be common factors. So take the minimum factor. So HCF of 16 comma 24 is equal to the minimum of 2 raised is 3, 2 cube. Now here 3 is raised to power 1, I mean 3 is there, but here 3 is not there, I mean 3 is raised to power 0, anything to power 0 is 1. So since 3 is not there, I will not write 3, so it's basically 1, okay, because 3 is not here. So the HCF is 2 power 3, that is 8. So, and through this technique of finding individual factors, we saw that it is actually 8. So in this way, using prime factors, we could quickly arrive at the HCF. Now let us take another example. So my second example is as given here, 24 and 36. Okay, that's 24 I kept as it is, 36 I will do here. Okay, 2 1s are 2 8s are. Now here 2 9s are, and sorry, it doesn't go by 2, 3 3s are. So the prime factorization of 36 is equal to 2 into 2, 2 square, 3 into 3 is 3 square. Okay. So now to find the HCF, I will write here it's HCF of 36 comma 24, these two numbers basically is, I mean you start taking the common factors here, common prime factors first, 2, now which is the minimum power raised 2 or 3, 2 is the minimum, so write it 2 square. Now second 3, Here 3 is raised to power 2, here 3 is raised to power 1. So take this into 3. Its name as 4 into 3 is equal to 12. The highest common factor among these two, because we know 12 3s are 36 and 12 2s are 24. The highest common factor of 24 and 36 is 12. So in this way we can use prime factorization very efficiently to find HCF, or the highest common factor. Now, having studied about highest common factor, what about multiples? LCM, or lowest common multiple. In the case of factors, we saw that factors are always less than the given number. But in the case of multiples, the first or the minimum value of a multiple is a given number. Okay, so multiples keep on growing infinitely. So in our session on multiples, we saw that multiples of 4 are 4, 8, 12, 16, so on, and multiples of 6, 12, 18, 24, 30, and so on. It goes on. So which is the least common multiple? 12. And after that, so we get 24 here. There is one more common multiple, that is 24. And maybe the next common multiple is 36. And it goes on. But the least common multiple is always a constant for any given two numbers. Okay. For example, given 4 and 6, the least common multiple is 12. So in this way, how to find the lowest or the least common multiple? So we will take the example of 6 and 8. Again we start doing prime factorization. 2 3s are. So 6 is equal to 2 into 3. But 8, 2 4s are, again 4, 2 2s are. 8 is equal to 2 into 2 into 2 is equal to 2 cube. So for finding the lowest common multiple of given two numbers, what do we do? In the case of HCF, we took the lesser power, but for finding lowest common multiple, take the maximum of the powers. So here we know the prime factor 2 is there, and 2 is raised to power 1 here, whereas 2 is raised to power 3 here. So take 2 cube, and 3 is raised to power 1 here, 3 is not there, so take 3 raised to power 1 is 3. So now get the answer as 2 cube is 8, 8 into 3 is equal to 24. So the lowest common multiple of 6 and 8 is 24, which we can always get by actually finding all the multiples of 6, all the multiples of 8, and finding the lowest among them. But the easier method is to just find the prime factors and then take the maximum of the powers of each prime factor. Okay. So in this way we can always find LCM. Now we can also use the concept of prime factorization to find what is known as a square root and a cube root. Now what is a square root? Square root of a given number is another number such that when you square that number, you get this number. So square root of 4 is equal to 2. Similarly, what is a cube root? Cube root of a number, given number, is another number such that you raise it to power 3, you get the given number. So cube root of 8 is denoted as, this symbol is equal to 2. So in this way, how to find, for smaller numbers we can do easily, how to find square root and cube root of large numbers. So we can use prime factorization for this. We have taken the example of 144. Now we start finding prime factors of this. 2, 7, 2, 2, sorry, this again 2, 2, 36, then we have 2, 18, we have 2, 9, and finally 3, 3. So we can write 144 as 1, 2, 3, 3, 4, 4 times 2, 2 power 4 into 3 square. So in order to find the square root, so we saw here if 2 square is 4, 2 is the square root. So similarly, let us find for each prime factor. Now here 2 power 4 is there. I can split it as 2 square into 2 square. Okay, because power 4 is 2 square into 2 square, and I can write 3 square as it is. So now the square is here, c squares. You can write this as 2 into 2 into 3 whole square. Okay, because square is common. Now 2 into 2 is 4, 4 into 3 is 12, 12 square. So 144 is 12 square. In other words, square root of 144 is equal to 12. So a very simple way to find square roots of large numbers. So now let us see how to find cube roots. So you have taken an example of 2 and 6. Follow prime factorization. Okay, 2108. 227. Now it doesn't go by 2, so next number is 3 9s are, 9 goes 3 3s are. So basically prime factors of 2 and 6 is 2 cube into 3 cube. Okay. So now cube, I need to have cube on each prime factor. So we have 2 cube and 3 cube. So we can write it as 2 into 3 whole cube, 2 3 is 6 cube. So 2 and 6 is cube of 6, or cube root of 2 and 6 is 6. So in this way we can easily find cube roots using prime factorization. So having learned how to find HCF, how to find LCM, how to find square roots and cube roots, so we want you to strengthen this understanding and concepts by solving these problems and understand how we can use prime factorization in various applications. But when the number becomes too huge, we saw that factorizing them into their prime numbers becomes quite difficult, and hence whatever we are discussing, the technique of finding HCF or LCM or even square roots and cube roots, it is simple and easy to do for smaller numbers. I mean, smaller means not too small, say a 4-digit number or a 5-digit number, maybe even up to 10-digit number. We will be able to use this concept of prime factorization to find highest common factor, lowest common multiple, square root and cube. So in this way we saw how every given integer is either a prime or it can be written as product of its prime factors, and using this concept of prime factorization, how we can apply it in various fields of mathematics to find highest common factors or highest common multiples or even square roots and cube roots and so on. So in this way we have completed our 5 module topic on numbers. Thank you very much.